Hello, my name is Vosburgh, and this is my presentation for the first interactive advanced concept presentation for Chemistry 2, which is titled Gummy Bears. First, I'd like to discuss the purpose of this activity. The purpose of this activity is to explain the principles related to solutions, explain how solutes interact with solvents, and explain if the activity went properly or if the results differed than what was expected. Some of the key terms that are important for this activity is solvent, solute, solution, osmosis, and concentrated. All of these definitions can be found in the textbook written by Julia Burge, Chemistry 2, 5th edition, published by McGraw and Hill in 2020. First is the solvent. In this experiment, this is the water. Next is a solute. For this experiment, that is the salt water, as well as the water that can be found within the gummy bear itself. The solution would be the salt water as well as the gummy bear. Osmosis is the process of a solute moving from one solvent to the other, and it's going from a more diluted solution to a more concentrated one. And then finally, concentrated, which is the amount of solute relative to the volume of the solution, or the amount of solvent in the solution. These are all important as we continue on to discuss what is supposed to happen with this gummy bear activity. Moving on to what should happen with this experiment, we will take a gummy bear, put a gummy bear that is a normal sized gummy bear into tap water with nothing in it, and then tap water that has salt in it to the point where the salt is not dissolving anymore, making it a high concentrated solution. With this, what should happen is that the gummy bear that is in the tap water should increase in size. This is due to a process known as osmosis, which is a solute moving from a less diluted solution to a more concentrated one. With this, the gummy bear is a more concentrated one, so water molecules are going to move from the water into the gummy bear, increasing it and making it increase in size. Moving on to the tap water, or the salt water. The salt water, when you drop a gummy bear into it, the gummy bear is not going to increase in size due to the fact that the salt water is more concentrated than the gummy bear is. With that, what would happen is the water molecules of the gummy bear, per osmosis, would move to the salt water. However, because the gummy bear is a solid, those water molecules cannot separate. Therefore, the water does not move to the salt water, causing it to shrink in size. Ultimately, the saltwater gummy bear should be the same size as the normal size gummy bear, because that process of osmosis is not happening or occurring like it does with the tap water. Moving on to what happened when I conducted this activity. When I put my gummy bears in, they sat in the solutions for approximately 7.5 hours. I dropped them in at 8:30 in the morning, and I took them out at 15:30-ish. With that being said, this is pictures of how they looked when I took them out of the solution. The normal size, obviously not in the water, the tap water one being slightly bigger, not a whole lot bigger, but slightly, and then tap water with salt water also being about the same size as that tap water gummy bear. My experiment did not do what I explained on the previous slide. The salt water solution did have osmosis occur, and it did do what the tap water did, which is cause the gummy bear to increase in size. My reason for why this happened is I probably did not add enough salt into the solution, making the salt water more concentrated than gummy bear. The gummy bear probably was still more concentrated, even though there was salt in the water. I probably did not have enough, meaning that the salt water interacted as if it were tap water, and the water molecules moved through the gummy bear, through the gelatin, and caused that increase in size. So in summary, my activity did not go as hypothesized or anticipated. However, we did see the process of osmosis occur by the increasing gummy bear size, and we understand why the saltwater solution caused osmosis to occur and how we can better this activity in the future. With that, again, all definitions were pulled from Chemistry 5th edition, McGraw-Hill, written by Julia Burge, published in 2020. Thank you.